Hey guys, welcome back. We're continuing on with three-phase. Lots to learn, learning lots today, I hope, guys. Here's our three-phase transformer that I'm going to look at here for a second. And don't sweat it, okay? I've got a transformer. It's got Y connected on one side and delta connected on the other. You can see and find transformers in every different kind of configuration, okay? It could be Y on the primary, delta on the primary, Y on the secondary, delta on the secondary. They can be the same delta, delta, Y, delta, delta, Y, 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 every combination you can think of, okay? And it's no big deal. We're just going to calculate everything going on with any kind of transformer. And you can already do all this, okay? Because I've actually shown you all the calculations so far except for this one, and that is the ratio. There's the ratio of the transformer, guys. And when you're talking about three-phase transformers, it's very important to remember that a three-phase transformer, doesn't matter if it's Y or delta, is going to be basically three single-phase transformers, okay? And they're going to be stacked like this. It might be three actual single-phase transformers, or it's going to be, one big three-phase transformer, but it'll be made up of three single-phase transformers. And then, whether it's Y or delta is going to, just be how it got wired up, right, guys? So the transformer actually doesn't care how it's wired. Okay, that's going to be up to the engineer who designed it, or the electrician who's wiring it, or the drawings, or whatever. Okay, so I'm just going to connect this thing Y here for a second. So I'm going to put my lines on there, okay, and I'm going to connect my other connections together like that. Okay, so there's my Y connected primary, and it looks like the secondary is delta connected, guys. And so for delta, I would just go like that, right, guys? Okay, so there's my Y and there's my delta connected three-phase transformer. And it looks like the ratio is 3-to-1, guys, and it's really important to remember that if you look at the transformer, the ratio 3-to-1, it's going to be from coil to coil. In other words, phase to phase, okay? And every time I do a transformer, ratio calculation, I have to remember that. Basically, it's going from that winding across the transformer to that winding, or that one, to that one, or that one to that one, right, guys? It's going to be phase to phase. So this is exactly like the questions in your homework assignment. And so we're going to do this one together slowly here, guys. And when you're calculating all, look at all the stuff that's going on here. It's giving you a line voltage, guys, 250 volts. That means if I measure from here to here, it's 250. Okay, and look, it's asking for the phase voltage on the primary. Now, you're going to have to get used to all my little acronyms here, okay? But if you look at it, it's always going to start with E or I, voltage or current. Then there'll be a L, or a phase voltage, which stands for line or phase, guys. And then there's going to be a P or a S, which is going to stand for, primary or secondary. So this is E line primary, okay? This is E line secondary. This is I phase secondary, I phase primary, I line secondary, okay? Always voltage or current, line or phase, and then primary or secondary as the three, initials, if you will. And it'll be a little weird at first, okay, guys? But hopefully it'll get easier. All right, guys? So here's our transformer, guys, and we're going to work it out. Now, you always work your transformer one thing at a time, okay? You're never going to go from E line primary out here to, E line secondary, okay? You're always going to go from line voltage to phase voltage across the transformer to this phase voltage, and then try to figure out the line voltage over here, which is the order at which all this stuff appears here too, guys. So let's do it one step at a time. It says the line voltage on the primary side is 250. That's from here to here. The first thing it's asking is, what is the phase voltage on the primary side? In other words, from here to here. All right, guys. Now, if that voltage is 250, more, less, or equal to 250, right there, guys. And it's less, right? Because that plus that is going to equal to 250. So E phase primary is going to be 250 divided by root 3. All right? And that would be right here, right? Oops, 250 divided by root 3. All right, so this is 144.3 volts, okay? 144.3 volts, okay? Now, next thing, E phase secondary. It's wondering about this voltage right here, from there to there. Well, it's going from this phase to this phase, okay, at a ratio of 3 to 1, which means that that voltage here, and these are all going to be step-down transformers, guys. All right, so I don't know, Van Andel always does step-down transformers, okay? So this is going to be 144.3 divided by 3. Not because it's three-phase, but because it's a ratio of 3 to 1, okay? So I'm going to take that number, divided by 3. 48.1 volts, okay? And it's really important that you're going from phase to phase. You can't take that line voltage and divide it by 3 and think you're going to get that line voltage there. It's not going to work that way, all right? It's phase to phase. Okay, so here's E phase secondary, guys. And it is 48.1 volts, all right? E line secondary. So I got 48.1 here, you know, here, but here too, right? And there. So what's that? Equal to, less than, or more than 48? And the answer is equal to, because it doesn't matter if I measure here or here. It's the same spot. So this will just be 48.1 volts, okay? And that is going to be E line secondary from there to there. All right, guys? So we figured all our voltages out. A primary and a line and a phase voltage on the primary, and a phase and a line voltage on the secondary. Now, we're going to try a currents. Look, it says the line current on the secondary side, which would be right there if I measured it, guys. Let's get a different color, right? That I line secondary would be right there. It's 11 amps, okay? So the question is I phase secondary right there. What is that? I phase secondary. Well, is it going to be more, less, or equal to 11? And if I have 11 flowing this way, that means some of it's coming from here and some of it's here. So it's going to be less than 11. Okay, guys? So it's 11 divided by root 3. 6.351 amps. Okay, guys? Now I'm going to go across the transformer from here to here at a ratio of 3 to 1. Now, this is the lower voltage, which means the current is going to be higher, right? That's how all transformers work. If the voltage is going down, then the current over here is going to be higher than there, right? So this current should be 3 times lower than that, which means that this current right here, which is I phase primary, it's going to be 6.351 divided by the ratio. Okay, guys? Divided by 3. 2.117 amps. Okay, does that make sense, guys? The high voltage is going to have the low current. Okay, so high voltage, low current, low voltage, high current. Okay, so that's that current right there, 2.117 amps. Okay, and then the last current I want to calculate is I line primary, which is that current right there. I line primary, okay? And is it going to be more, equal to, or less than 2.117? Equals, okay? 2.117 amps. Equals because it's all in series. All right, guys? So that's how it's done. I know I went fast, but on your homework, you're going to be taking your voltage, line voltage, calculate phase voltage, calculate phase voltage, calculate line voltage, okay? And then the current's the same thing. You've got your line current, work it back. Phase current, go across the transformer, phase current, over to line current. All right, guys? And you must work it one step at a time, okay? Last thing before we go, we're going to calculate the VA on the primary and secondary, okay, guys? And you can use any formula you like. There's 2 of them, right? But I'm going to use line values. So VA primary, it should be equal to E line 250 times I line, which we calculated right here, 2.117 times root 3, since I'm using line values, guys. If you're using phase values, it's E phase, I phase times 3. If you're using line values, it's E line, I line times root 3. And you don't want to mix those up, okay? Root 3 with the line values, 3 with the phase values. And we could have used phase values, okay? We'd get the same numbers. In fact, if you want to try it, you can, okay? So 250 times 2.117 times root 3, okay? Looks like the VA for this guy is 6.7 volt amps, all right? And that's on the primary side. We're going to make the same calculation on the secondary side here, guys. It should be the VA E line, I line, root 3 on the secondary. So if I look at my line values on the secondary side, E line secondary is 48.1, okay? I line secondary is 11 times root 3. Let's try that, okay? 48.1 times 11 times root 3. Looks like it's 916.4 volt amps, okay? And now I want you to notice that the VA on the primary is equal to the VA on the secondary, okay? And that's always going to be true. I don't care what formulas you use, okay? If you're getting two different VAs from your calculator, for your transformer, you made a mistake, okay? You used the wrong values, the wrong formulas, the wrong, something. I don't know what. All right, guys? So, Unit 4. Handout 1, okay, guys? And give it a try. And tomorrow we'll be adding a load to those transformers, or the next lesson, I guess you could say. Have a good day. Bye-bye.